I'm Paul Nadir. For those of you who don't know, we're going to talk about the CAD Cleanup competition just briefly and then cover the what's new as mentioned. Since we haven't had one of these sessions on every new release or every year, we will cover more releases today than only the current one and focus on the tools that many people don't even know about, but which can add enormous value to you. As you know, the world is moving on and at such a high speed and increasing pace every day that it's tough to stay on top of your game and relevant in your field of expertise. So the aim of these lunch and learn sessions are to share valuable information with you on the products and technology that you already have access to and that you know will benefit you in some way. The MSC Apex CAD Cleanup competition is also currently underway, and from the submissions so far, it was quite interesting to see how everyone obtained the same result, but using different tool sets. And of course, the winner in each round was the person who used the fewest tools to accomplish the task in the least amount of time. And this is exactly what these lunch and learn sessions are for, to share tips and tricks and always to work faster and smarter. If you're currently on MSC Apex user, have a look at this video from Hubert van der Merwe from ENSA, who managed to clean up this non-analysis ready solid CAD file and produce a mid-surface run ready analysis model in only under 2 minutes. And this video is currently playing at real time. They're featuring the model, removing some fillets, some holes, creating the mid-surfaces of the solids, extending and stitching all of them. Now remember, this is in real time. Manually editing a few things that didn't come through nicely. Thanks a few touch-ups here and there. Splitting the edge so that we can create welds where these plates have large offsets, and using those splits to then create fillet plates to represent the welds. Cleaning off a little piece of plate there. It's not supposed to be there. Using one of the custom tools to load a list of materials. Apply the required material to all the properties. Those properties were created during the mid-surface. And the new plates that the welds that he created gets their own property, and there's the job run. So for the competition, they only have to measure the time from importing the solid until submitting it for analysis. So the time it takes to analyze doesn't take into account. And there you have it in under 2 minutes. So this is just one of the examples. Sorry, let me just stop that. So this is just one of the examples of a user who's regularly in contact with us and is always eager to learn and try out new methods to be more productive every way. The competition is still running, and the videos of the front runners in the competition are shared with everyone at every stage. So everyone competing is picking up new ways to work even faster. The top 3 contestants will win a free entry to our users conference that is taking place on the 17th of June. And there the winner will be announced and walk away with a pair of augmented reality glasses worth around 10,000 Rand. Now let's move on to what is next on the agenda for the what's new in Apex since 2021. Since the start of 2021, there were 16 new releases of MSC Apex, That's an average of 3 releases per year. And in total, 92 new features, as publicly published, were added to Apex and 80 enhancements to existing features over these 5 years. Initially, the idea for today's Lunch and Learn session was only to cover the last few release highlights. However, we found that there are so many high-value features that were added over the years that many users are not aware of. I decided to highlight as many as we can fit into an hour from the past 5 years at least, and focus on those that you can add that can add the most value to the most of you. I grouped the new and improved features into these 8 categories: CAD cleanup, meshing, solver support, usability enhancements, loads and boundary conditions, post-processing, custom tools, and other. So I'm launching this poll, and I'm asking you if you can rank these categories of features in order from those you feel that still need more features or enhancements and are the most important to you at the top, to the least improvements needed or the lowest priority for you at the bottom. I'll give you a few moments to rank these categories and then submit your opinions. Oh, excellent. Okay, this is quite interesting, and this is definitely feedback that we will be sharing with the Apex development team as well. Gives them a good idea of where to focus their attention next. So thank you very much for those coming in. It seems at this stage, post-processing is at the top of the list, followed by CAD cleanup and then loads and boundary conditions. This table that I'm showing over here lists the number of new and enhanced features for each release since 2021, according to the mentioned 8 categories of each type of feature. As you can see, the categories that received the most attention up to now was solver support in the first place, followed by meshing and post-processing. Now let's go through the list of these new and enhanced feature by category. In the CAD cleanup category, the most notable ones were as follows: mesh to CAD enhancements, geometry cleanup tool extended to facet to include faceted bodies. The feature tool improved for cliff fillets, you know, those ugly, not ugly, but inconvenient S-curves when there's two fillets attached to one another. So that is an improved feature. And then the interface point creation, very important for Adams users, where there's a joint that needs to connect to the flexible body. The interface that you create in Apex essentially dictates where the load at that point needs to attach to the FEM body. The plane creation at arbitrary location and orientation is new. Then the option to retain original curves in filler surface creation. This is when you use 2 curves to create a surface. You now have the option that those curves stay in the tree. In the past, they were removed. Then there's the part merge or split tool. What this does is it gives you the ability to quickly change from a single part with many solids to many parts, each one with one solid, or vice versa. So you can very quickly rearrange your model assembly in a way that fits your needs. And then there's the transform tool improvements for alignment, coplanarity, and parallelism. And then the mid-surfacing solids with cell bodies. So this is when you have a solid, you've partitioned it, most likely to create a hex mesh for it. And then after realizing that you maybe need to mid-surfaces, you couldn't mid-surface it until you've merged all those cells again. That is not a limitation anymore. So now you can mid-surface or create mid-surfaces from a body, even if it was partitioned into cells. Right, that's it for CAD cleanup. On the custom tools side, now we're not listing all the tools themselves, only the environment of these tools. Is the ability to have multiple custom tool palettes was added in 2021. The scalability of the palette through groups and tool definitions was also in the same version then, followed by a comprehensive post-processing scripting API that was now possible, and the IntelliSense for scripting. So as you script in your favorite editor, the IntelliSense essentially starts populating the rest of the framework or the codes that you use. And then we have the user-scripted scenario creation. So that wasn't previously possible. Now you can do that in your script as well. And then the scripting for modules and plots was enhanced. I mentioned here that the custom tools are non-standard features yet that you need, and some you didn't even know you needed. If we have time after going through all these lists, I will try to highlight a few for you in a brief demo. Then let's move on to loads and boundary conditions. So there was a lot of thermal related additions and improvements. Then traction load was added in 2021.2. That is essentially a surface pressure, but having shear along the surface. And then the lug load was added. So 400 subcase step and simulation settings were improved. And then the create fastener element by property was added. Now, fastener in this case is actually a Nastran entity that is created using simply a node. And then in this case, it can identify when two properties are in proximity of that node to create the fastener entity there. Whereas previously it was simply between selected surfaces. Now you can enhance it so that you don't need to select all the surfaces. You can only, you can simply just select properties. Then we get to the meshing category, which is a considerably longer list, and we have a few slides on that. So first thing there, shared nodes between parts. So that was new. In the past, you could not merge nodes if they belonged to different parts. It's now possible. Mesh control points and curves work with the transform tool. Improved facet body incremental meshing, improved meshing of organic shapes. Mesh flow optimization is now enabled by default to help the mesh flow along curvatures or feature lines of your geometry. There's improvements on the face mesh growth transitions. And then from 2021, you could now move an orphan mesh between bodies and parts. Previously, it was basically stuck in the part that it was imported into. The quad elements on boundary option with mixed surface meshes is now possible. So this essentially enforces quad elements on the boundary of the surface, whereas you may still use triangles in the middle of the mesh. And then there were 2D improvements, and then mesh diagnostics. This is focused on specifically solids for hex meshing. If the solid or the partition is not hex meshable, you can use the mesh diagnostics, and it will tell you exactly why it cannot hex mesh it. And that's very useful to then help you decide how to further subdivide it to make it hex meshable. And then the addition of mesh transitions for solids and shells was added in 21.3. As you can see then, a lot of improvements from hex mesh improvements, seed point connection, persistence, enhanced geometry splitting, surface meshing improvements, more surface meshing enhancements, improved surface meshing performance, improved initial mesh quality, more hex mesh enhancements, and then curvature-based refinement for facet bodies were added, as well as proximity mesh refinement. What proximity mesh refinement is when you, let's say, mesh a washer around the hole, but that washer or that hole is very close to an edge or another geometry feature. The proximity mesh refinement will then improve the mesh even if it needs to disobey the washer definition. And the same for other features as well. Then there was the thickness proximity sensitive tetra meshing as well. So what this meant is when you specifically have thin sections in a bigger solid, it could take that thickness into account and create a better mesh in those regions, and far less likely elements that would fail the quality test. In 2022.4, we received local pattern meshing. So this is where you use an existing mesh as a pattern for meshing the rest. Enhanced mesh layer control in solid meshing. So that is quite useful, especially when you have thin areas in a solid where you want a specific number of elements through the layer. The improved edge-based curvature refinement came in the same version. Then the addition of hybrid hexa and tetra solid elements. Now this one I just want to spend a second or two. So this is basically a third option, whereas the first option is tet elements, then the hex elements. And this is now where you have a mix of tets and hexes. Please be very careful. The default currently is to create linear elements, and you should never use that. That's illegal and dangerous. Always use the quadratic option when you go for the mixed mesh elements, regardless of whether you have tets on the surface or hexes on the inside, and vice versa. Always use the quadratic elements, otherwise you will have linear tetrahedral elements, which gives really bad answers. So just be aware of that one. Then the shell meshing edge curvature refinement for facet bodies was further enhanced. Hybrid mesher robustness improvements were added. The shrink wrap meshing across assemblies was added in 23.3. And at first glance, you have no idea. It looks very cool and impressive when you see it, but you have no idea necessarily what it's useful for. But it's actually extremely useful for anyone doing acoustic simulations, where you then literally take, it's literally like shrink wrap that you fill or stretch over the whole model, and it creates a mesh around that, essentially filling any small gaps or ignoring small features, and just creating a nice closed mesh around the whole assembly. But as I say, not as useful for structural analysis, more used in the acoustic simulation side of things. Some people even use this for CFD preparations. And then the try reduction tool for shell meshes was also introduced in 24.1. The mesh control APIs were also enhanced for using selected elements. So this gives people creating scripts the ability to have you select elements and then provide the script access to mesh control tools that you would otherwise need to use manually. And then there's the interactive control mesh tool. So this is a new addition as well. It's in the meshing environment, just underneath seeding. And this is quite an interesting one, where you have now additional tools of manipulating the mesh locally and not necessarily damaging or adding features to the surface or solids. So that is worthwhile looking into if you ever had the need for something like that. And then the improvement of meshing for skinny surfaces and composite layup and zone meshing improvements in that release. Bring us to the last slide on meshing. So again, mesh improvement tool that was added, hex meshing with mesh controls and seed points. We improved skinny surface and proximity meshing that produced fewer triangles. That's a new enhancement. And then the quad-only meshing or warning and dialog control. That was to tell you that even though you selected the quad-only mesh option, it was not possible, and it just warns you that there are a few triangles. So it doesn't fail. It simply warns you that there is a solution, but with a few triangles. Then the faster and more robust mesh-dependent ties without virtual edges was improved. Node merge improvements, hex meshing that preserves mesh control shapes, improved skinny surface meshing with fewer triangles, and then adding the viewport editing of edge seedings and the suppression of internal cell edges for cleaner hex meshing. So this is also a useful one when you take a complex solid and you partition it into these cells. Sometimes you sit with a lot of cut planes internally that goes from side to side, and you could improve that by merging certain cells or changing the sequence in which you've subdivided it, or you can now suppress them internally to improve or manipulate the way the mesh is created. So that's quite useful. And then on the post-processing side, the Nastran pre and post-processing was expanded, frequency response post-processing was improved, targeted vector plots was added in 21.2, nonlinear post-processing came in 21.4, cut planes in the post-processor were added, the improved solution 400 setup and post-processing was enhanced, and then the visualization or post-processing of MSC Nastran modules. We haven't had a session on Nastran modules yet. I think we will do so in the near future or at some point. Nastran modules is very similar to super elements. It's just much easier to use, and you don't need to be a Nastran guru to set up a super element. It's another way that large organizations like Airbus and other aerospace companies share submodels with their suppliers and vice versa without exposing all the intellectual property on the inside. Then chart persistence and multiple chart views was improved. Post-processing of Nastran modules for solution 400 was added. Support for Nastran output requests were added. The improvement of Nastran pre and post-processing. And then H5 attachments for faster post-processing was added in 23.3. Next slide, the additional MSC Nastran outputs for existing sequences, dynamics pre and post-processing support, post-processing in new and legacy scenarios. So yeah, we haven't talked about that much, but Apex underwent a big change from preferring the internal solver to now exclusively supporting the external Nastran solver. And that meant a lot of changes because the user interface now supports Nastran, but that made some setups a little bit more difficult for new users. So there's a lot of changes and transition in that process, and that involved post-processing as well. Then added support for 32-bit HCF5 files, global plier results, and progressive failure and composite property additions for post-processing composite materials. Then the section force sensors that are now available in post. Previously, you had to create or set them up in the preprocessor and then switch back to the post-processor. These can now be created directly in the post-processor. Then plot targeting for groups or visible entities. That's quite useful and highly requested for a long time now. Then the context-aware post utilities, and then the addition of vibration view for dynamic analyses and the review of post across multiple models. That's also new in 25.2. Then on the solver support front, this is the category with the longest list of all. So let's see if we can run through this and still get to a few demonstrations. So it's the C-gap connector GUI support was added in 21.1. Coordinate system assignment at nodes, MSC Nastran include file support. 2D element properties tools Broader connection support was an enhancement. Then the PComp G import and export. Important for people using that. Non-manifold composite panels, structure solver migration to MSC Nastran for linear static models and buckling. So this was from the internal solver to the external. No ties, replacing VOM points and distributions. Nonlinear scenarios and steps can now be set up since version 21.4. Elastoplastic materials was also added then, and nonlinear contact as well. Then there was enhancements in the extended include file support, more PComp export enhancements. 3D bolt modeling was added. 3D element property support. Can't remember exactly what it was of the 3D element properties that were added there, but we can look into that. Then the P-Solid PID preservation, the CFast enhancements we mentioned earlier, stronger MSC Nastran nonlinear support, integrated Nastran execution. This was also quite a useful one that you didn't only or you didn't need to export your PDF anymore to solve the job with Nastran. You can now directly execute it as you've probably always been used to before. And then the referencing coordinate systems on parts or M&F bodies. More 3D bolt enhancements, the introduction of SOL 400 flexible contact bodies. And then the new MSC Nastran materials support was added in 22.4. Also in 22.4, new MSC Nastran property support, new MSC Nastran table support, better shell abstraction enhancements, automatic P-shell creation during mid-surfacing, constant offset thickness tool, the support for MSC Nastran loads, constraints, initial conditions, parameters, and system cells. So you can see a lot of enhancements to support Nastran fully. Then the pre-processing for modules. Then the expanded direct external MSC Nastran execution enhancements, property view for MSC Nastran property assignments, broader MSC Nastran case control and solution sequence support, and then full support for the major linear dynamics and nonlinear SOL 400 workflows were further enhanced, and then support for the new MSC Nastran nonlinear solver. Right, next slide. Next is compute, cloud, solve, and monitoring. Also, the fact that you can submit these directly from Apex to solve your solutions in the cloud. Stronger module workflows, new style module scenarios were added, module export execute, automatic and user scripted scenario creation options mentioned that as well. High performance nonlinear solvers is now the default. The SOL 400 transient support was added in 25.1. Beam span, property object, pin flags, G0, and shear center controls. This was also added to Apex in that release, and then the H5-based scenario model importing. Then the faster solve performance of large NSM models were improved. One element property catalog workflow is new. So they changed the way in which you create and manage your beam element properties and sections and so forth. And then the addition of nonlinear beam properties. Then exploded view. So we're back to version 21, but we're now at usability enhancements. So exploded view, very useful in these large complex models, was added in 2021. The basic and advanced tool category organization. So what they've started doing in 2021 was to hide advanced tool options and make them accessible for experienced users, but don't intimidate new users. Middle mouse apply was added in 2021. I'm not so sure about that one. In my mind, it was there from the start, but for some reason it's listed here under 2021. Automatic and manual mode toggle was also added in 2021. The group creation tool was added. All the diehard pattern users kept on requesting groups, so that was finally added in 21.2. Then the easier coordinate system assignment workflow was improved, exploded enhancements for logical model connections. So that was a useful one. So when you explode your view, you can see where the connectors are attached to. So that's quite useful, especially when those faces actually touch one another in the normal view. Then enhanced face selection, improved animation performance, utilities and help improvements, unified installer for Apex and generative design. So this is an important one. It's also mentioned somewhere else that you now switch between Apex and generative design within the same user interface. So it's no longer two different installations. And then in 24.1, the direct visibility of MSC Nastran entries on forms. Right, and then lastly, the improved direct text input, the mission shoots between MSC Nastran modeler and generative design that I've just mentioned. There's a new database repair tool. So there was a lot of challenges with customers with large models. And then at some point, the database would just become unmanageable or slow or corrupt. And they've introduced a database repair tool to essentially recreate the database or clean it up, or not 100% up to date on all that happens behind the scenes. But that tool was introduced and available and resolved a lot of problems for a lot of customers. Sorry. Then there's the improved recovery file naming and reliability. So that also helped to recover models. Then there's better panel and stack management for composites and the way they name and create those. Then the batch or context actions and clearer panel organization. That's also for the user experience. And then the visibility of secondary modules and transform reuse. And then lastly, multi-model workflow support. So now you can have multiple models in a single model or Apex project. And that was added in the 25.2 release. And then just lastly, a few other features. So general usability fixes that was done in 2020. 2021 remote control user interface that can be shown or hide. 22.1 introduced ID management of entities, and 2023 was a huge bug release, a big bug solve release, about 160 issues that was resolved in that single release. And then since 23.2, you can execute the external Nastran solver using the Running Man icon without having the Apex structures license active. Only modeler. And then lastly, the large assembly and mesh operations performance improvements. Great. So it seems like we've kept the time within limits. So let's have a quick look at some of the user tools. Now this is unprepared, so yeah, let's see. As I mentioned, there's 160 odd new custom tools. So this list is extensive. We're getting at the point where we've been complaining for a few releases now that there's not enough space in this toolbar. So hopefully they'll introduce a better solution. But currently, if you see a little, and it's not always that clear, if you see a little triangle or expansion icon over there, that actually means that there are hidden tools in this tool group. So if you move the next group down until that little arrow disappears, you've now hid and hide all those tools. But if you need to have these ones exposed, you need to do the opposite. So the custom toolbar is quite long over here, and it's been, just close that one. It's been reorganized as follows. So the first one is your attribution utilities, and the shortcut name that appears over here is also shown over there. And then inside you have these groups. So first we get the attribution group, then the composites group, then the loads and boundary group, more contacts, more materials. And as I've mentioned, all of these tools were created by individuals at Hexagon. So it's important to understand they have not gone through the rigorous testing that the core product goes through or has to go through, or the processes that product development goes through. These are all editable Python scripts. You can actually find each one of them. If you go to your working directory on your computer, so if you go to the MSC Apex workspace, you can find the custom tools files of all the versions that you have installed. And under Apex Utilities, you will find the exact same order. Attribution is the first folder. Next one is education, fastener, etc. And if you enter any of these, you will find subfolders. So that create fastener is the first group that you would see over here. So create fasteners is a folder, and that essentially creates this group. So if you add anything in this folder, that will add your tool or your script in this list over here. So here we can see the further breakdown of tools and their details in here. And if you go deepest, you'll find always these 3 files, and the only one you need to create is essentially the Python file over here. And if you need a form for interaction, you will be creating that little guy there as well. So that just gives you this ability, like for instance, the moment somebody uses and selects your tool and a little Python window needs to pop up, that will then happen, and this is what you designed. So that is how the setup works. So let's just quickly run through this in a few minutes that we have left. There's a few noteworthy ones in this group. So let's start with attribution. This is the point mass from Solid Tool. This is actually surprisingly useful one. Let me just see if I can. Unfortunately, the video preview pops up on the other screen, so you can't see the preview. But if you have large assembly and there's a lot of significant mass items in this assembly, let's say you're working on an armored vehicle and there are crates and toolboxes and radios, all items that has a significant amount of mass that needs to be taken into account in the structural analysis model, but you're definitely not going to FEM them. You can simply use the CAD geometry to create the point mass with the same mass and inertia properties at the center of mass of that entity, and then you have something that you can then attach using ties to the attachment point. So that's a very useful one. Here are some enhanced dynamic response plot enhancements. The global local is an interesting one. I wish I could get this to actually, let me just see if I can do something like this. It's useful to show the preview to explain this a little bit better. Let's see, I can drag it a little bit further out. If I can do it till here. Great. So you should at least see the preview. So there was the point mass one that created a point mass based on geometry for you, plot dynamic improvements. The global local one's very useful, where you have a large model and you're defining an active region in the middle where you have the detailed FEM. And it then creates the super element model of the large structure that you don't need in the detailed analysis, but that you need its impact or effect or boundary conditions for the smaller model. So that's a very useful tool for that. Finding missing material orientation. So this is where, for instance, for composites, you need to know what the material orientation definitions are. This is not needed for isotropic materials, but for your anisotropic or composite materials, you might need that. This is the database repair tool that I've mentioned. Then there's a whole bunch of tools in composites. So if you use composites, it might be worthwhile going through these tools. Now, as I mentioned, these are all tools that are created not by the Apex development team, but by individuals. So over time, these get integrated or replaced by main user tools. So if you find any new release and your favorite script is gone from here, it doesn't mean that it's gone. It just means that it has propagated into the main tool. So that can happen. And then you know what that was for. So before we had the 3D lug load in the main user interface tool like we have now, there was this little script that can do it for you. Similar distributed load on straight edges. Very useful for the education users. Use that a lot. In industry, we don't use it that much. That's why it wasn't really a priority for the development team. The equation field is useful if you have a equation that dictates the field, or it could be a pressure, it could be loads, anything that's not constant. The hydrostatic pressure was actually created by our own Gerrit and adopted in here. It's essentially an easier way of using the equation field to define a hydrostatic pressure by applying or defining the zero level of the fluid internally with a plane, as shown in this case, and then the rest of the pressure is automatically calculated for you using the direction of gravity and the density of the fluid. Right, the spatial mapping load tool, it's a very useful one. I covered that one. You can swap RBEs, the types of RBEs. Currently, the user interface does not allow you to change an RBE2 to an RBE3, or as Apex calls them, rigid and compliant connectors. So this tool takes care of that for you. And then the display of spatial load. So this was now obviously needed for these hydrostatic pressure or the equation fields, because the standard user interface doesn't have a way currently to display them. This tool helps you with that. Right, then there's a comprehensive contact edit tool. This is very useful for quickly swapping between rigid touching contact and permanent contact, breaking contact, etc. There's a contact wizard. I didn't even go through that one, so I'm not even sure what that one does. Coloring coloring materials, quite useful, so that you can visually get feedback of which materials were applied where. That's useful. My Materials is a tool that loads everything that you have populated in the specified spreadsheet. So that's quite useful. You can group your types of materials in tabs over here, and every tab will then show up in the little user interface, and all the materials in that tab is then automatically loaded into Apex when you click that button. There's some others. This one imports materials from BDFs. So if you have a PDF of a model with some specific materials in there, you can simply load that PDF, and that will also load all the materials. So you can see loading materials was a big topic early days. So you'll probably find that these scripts were all written by different people, and they all have some or other special way or something people prefer. So we actually have all of them here. So this one loads a standard set also from a list of PDFs, etc. This one was an interesting one that I found yesterday by accident. Don't know who will need that or when, but if you need to create a honeycomb, you can specify the cell sizes and the distance between plates, and creating that literally executes almost like a CAD pattern for you. And there you have a honeycomb that is created, the CAD is created, and the mesh is also run as well. Now I see for some reason this is now executed an analysis. I must have missed that stage yesterday when I played around with it. I think it was because I deleted the loads. But yeah, now the script is even executing the analysis. So we'll have to see what that does. Sorry, this wasn't planned and is now preventing me from continuing the quick discussion over here. But from what we can see, so there's other scripts there. Okay, wait, let's see what's happening here. Okay, cool. So this was set up in a very specific way. Mesh seems way too coarse to my liking. But in any case, there's the honeycomb, and if we hide the mesh over here, there we go. That was the geometry that was created. Okay, now I'm not even sure where were we now. Okay, over here. So yeah, if you play around with this, maybe if you delete the force, it won't execute the analysis. But that just shows you the power of scripting and what you can do. Right, so that was all for attribution. The second one is some education examples. If you're interested, you can have a look at this. So these just does a very basic standard model that it creates and set up for students for demonstration purposes. Now, Philip Lechtart from Stellenbosch University is actually working with the person responsible for these tools to actually include more of these examples. The bolt tool or the fastener tool one is another tool set that gets a lot of attention and is used by many people. The ability to identify holes where bolts or fasteners will most likely be created. The other ability to create them between points and nodes. Here's another one from an MWF file format. So that's some standard file format for the manufacturing industry, and it can then use that and create connectors between meshes at those global locations. If those connectors are at arbitrary locations and not close to a node, these spiders can then attach the adjacent nodes of a single element, or however you specify that, so that the load is not transferred at a single node, but maybe over a larger area. Identify bolts is a very cool one. If you have physical CAD geometry in your model, and these are typically always very detailed, there's threads in there, there's washers in there, and a lot of physical geometry that you don't need as an analyst, this can identify them and replace them with simplified geometry and reconnect the faces again to actually represent bolts. Here's another one, identifying bolts from holes, creating bolts from the fastener lines, or creating 3D geometry. So you can literally go from detailed geometry to a simple connector back to a fully 3D but simplified. And then fastener mesh controls, so that gives you even more opportunities to create fasteners at specific locations, creating mesh with control patches. A Rudman fastener is a very specific type of fastener. Deleting of those fasteners and fasteners from curves. So this could also be quite useful, as is shown in this example. And if you want to get more information on this, you can just simply play the help video or open the documentation that was created for them. The users of or creators of these tools don't always put everything in documentation, but they do try to make it easy for customers to use by putting in some effort, at least to have a HTML page and a short video that explains how the tool works. Okay, then more updates on C bush elements, updating of connectors, zero length connectors, how to deal with them, flexible vectors, and then creating of seam welds. Now this is quite an interesting and maybe useful one for you. If you only have these two bodies, this tool actually creates the geometry as well as the mesh for you that has to represent the weld. So you can definitely look into that if you ever need to do that manually. All right, then let's move on to more utilities. This is now the geometry and FEM utilities. As you can see, the list is quite long and we only have 5 minutes left. So let's see. There's a manual mesh extrude. If you have a surface mesh and you need to create a solid mesh from that, that's utility for that. So this is when you don't use geometry to do that. The more traditional mesh sweep tools, mesh revolve tools, you might have work for that. Mapping 2D element properties to, what was this? From the source surface mesh to the target surface mesh. Okay, so a lot going on here. Associated meshes, converting mesh dependent ties from one to the other, hex layer and hybrid meshes. Here's an example. I think this one was also created before these tools were introduced in the core tool. And also the ability to combine TET elements into hex elements. It's an interesting one that I've seen. Not sure what the benefits of that is, but apparently somebody wanted that. And then feature mesh settings library. So this is basically expanded version of a current mesh settings that you can set in each model. This is where you can actually build up a library for yourself. Right, then getting to geometry, creating a lot of interpolated points along a curve. So that's quite useful in some cases. Creating specific surfaces, label-free edges, finding short and small edges, remove duplicates. Strangely enough, not something that typically happens in Apex. But if you do find a duplicate surface, it might be difficult to find where they are or how to get rid of them, and this tool helps you with that. This is an interesting one, to disassociate a mesh body from the geometry. So typically when you have geometry and you mesh them, if you mesh the surface, the mesh is deleted along with it. But in some cases, you might have a meshed body, and for some reason you want to get rid of the body but retain the mesh. You can now do that using this disassociate tool. Okay, finding near and penetrating solids. This is quite useful as well. Some CAD tools have that ability. This basically helps you to find where solids are close to one another within certain tolerances or even penetrating one another. Then the showing of associated meshes, repeat copies. So we know that the current, well, that's actually not true anymore. The translate tool, the original one, didn't have the option to create multiple copies. But the new one, this was actually a custom tool. And this one do have the option to have multiple copies, depending on which one you use there. Okay, so let's just get back there. Sorry. Back in here. So this is basically a old script there, bounding region, if you want to create a block like that, projecting points, creating cylinders along a line, but this can also be done in the standard interface, unstitching of cells. So this can be useful if you've partitioned solid into these blocks and you now identify that you don't want them to be part of the same solid anymore. You want them as different solids. You can essentially unstitch it and then you sit with two solids and not just a partition solid. Same for edges that you want to, sorry, what did I do now? Curve between curves, so interpolating, if you have some reason to do that and you didn't do that in your CAD product, you can do that. Rotating and aligning by 3 points, but this is now also included in the new translate tool, but quite useful. And transform with properties. Yeah, so this is one of the embarrassing features that the standard translate tools still don't have, to actually copy the properties along with the geometry. This tool at least does that for you, so you don't have to go through that painful process if it's not needed. And we've only covered the first 4, so not a lot of time. No, there's actually no time left. I think we can definitely spend a whole session on what is left here. So here we have the interoperability. I found a few useful tools in this group. The modeling assistant, so worthwhile going through those. NVH is only for noise, vibration, and harshness studies. Some optimization utilities, query tools down here, synthetical solution tools over here, and then lastly, just a few standard views that you can use to set a few standard views. Okay, so great. That was that. I think most importantly, if you're interested in more information, the release guides are always populated with the installation files of each product. So where you find your install file for your software, you will also find the release file. So very useful to go through that. They are also either in a different format or in the same format published at simcompanion.hexagon.com. This will obviously soon redirect to cadence.com. We'll see what the new address would be for that, but under the release highlights tab, you will find those. And then a last poll before we finish off. I'd really appreciate it if you can give us some idea of any features that you still miss. So I'm putting up this launch. I'm launching this poll at the moment. Just give it a second. There we go. So please enter any feature that you miss or that you feel needs further improvement. So anything that you haven't noticed, or even if you've noticed it, but you're not sure, it's more than welcome to put it up. We will get in contact. If it is something that already exists, we will help you find it or get a better understanding of why you listed it. Maybe there's some enhancement that you've requested that you would like added. I see somebody wants some months and time. Okay, we have some spare here at the office. You're more than welcome to come past and collect it. I'll give you a few moments to add your wishes there. And then before we go, please take note of the upcoming events. The Cradle What's New will take place in the same format as today on the 22nd of May. The Adams What's New on the 5th of June. And then our annual users conference. The registrations are closing at the end of next month, so be careful that you don't miss it. please register to attend the users conference. And then the last, well, not the last, but the following lunch and learn would then be on Adam's flex bodies, and a session dedicated only to flex bodies. So thank you very much for your attendance. Thank you for your contributions. I see a few feature listings here. Please get in contact if you have more information to provide us. I see better tools, so not much I can do with that unless you provide us more information of what exactly you mean, or examples of what you mean. Then we can most definitely hand that over to the development team. As you know, we've got the direct line to the head of development and many of the technical team and pre-sales guys as well. So thank you very much for attending, and see you next time.